Okay, so yeah, I will do the coding practice as usual today. Okay, so today's question is on the linked list. Yep. Okay, so here's the question for me. So you were given the head of the linked list. They read the middle node and return the head of the modified linked list. The middle node of the linked list of size n is n divided by 2 node from the start using zero-based indexing, where x denotes the largest integer less than or equal to x. Okay, 4 and 1, 2, 3, 4 and 5. The middle node are 0, 1, 1, 2, and 2 respectively. I see. Okay. So, yeah. So in this question, I will be given the head of the linked list and I will modify it, yeah, mutate it. Then I will return middle of the linked list. Returns the head of the notified linked list. Okay. So remove middle node. Okay. So yeah, I will implement the function like remove middle node, and the argument will be the head of the linked list, and I will return the head. So and the side effect of this method is that the linked list, I mean the middle node of the linked list would be removed. Yeah. And yeah, that's the thing. Also, in many cases, the return head is exactly the same head of the given head as an argument. But as I can see from this example, if node is only one, the node should be removed. The only node existing is removed, so I will return none. But as from that, I will return, yeah, I will return the original head as it is. Yeah, okay. So that being said, so yeah, okay. So what I can say from this example is that head is not none, right? But this is guaranteed, or I should say, I will define the data input constraint as like that by myself for the, convenience of my coding practice by myself. Okay, so this is the interface of the method. So I will be thinking this with some examples. So if n is 1, so head is pointing to 1, and this should be removed. So I will return none because there isn't any node remaining. And for n is 2, head is pointing to 1 and 2. And because middle index is the square bracket 2 divided by 2. So this is the largest integer less than or equal to x. Okay, so this is 1. So this is 1, 0 index. If n is 2, oh, so no, sorry. So if n is 2, this one is removed. No. Yeah, this one is removed. So I will return given head, but as I can see, this node 2 is deleted. And when n is 3, middle node is 3 divided by 2, which is square bracket of 1.5, which is 1. So in this case, oh, sorry, wait a minute. So why did I do it? So probably I can do it in this way. So yeah. There is 3 nodes, so 0, 1, 2, and I will return this one. Okay. And I will return given head. Okay, so the thing is clear right now for me. So what I should do is that I will find the index of the node which should be removed. Then I will go there by traversing the linked list node by node. Then I will remove it. Then I will return the given head, basically. Okay. Yeah. So I will treat the n is one case, the case of n equal to 1 as the edge case, and I will return none in this case. But aside from that, what I should do is, as I said, find the middle index and move. Okay, let me write it down. So in this case, I will return none. I can treat it this as a kind of edge case, and aside from that, calculate get middle and move middle minus 1 times in linked list. Then remove the next node. Then I will return head. Yeah. Yeah. So yeah, this is what I'm expected to do. So let me do the complex analysis. So the time complexity would be the O of n. More accurately, I will traverse n divided by 2 times in the linked list, node by node. So n divided by 2. Yeah. So in the bigger notation, it should be O of n. And yeah, aside from that, all the operations are takes only the constant time. Okay, so the first space complexity. I don't need any extra space, so yeah, all of the, I mean, so it should be all of 1 constant. Okay, so let me go with this implementation. So let me write the test cases first. Okay, so I will define the node class. So with this, I will think of some test cases. So obviously, one of the case the first thing I'd like to write is when only one node, where I should say n is 1. So in this case, this should return none. And let me write 2 cases, and it's 2 and then it's 3, because I'd like to test either, at least one of, one test case for each of n is even and n is odd. So yeah. So here I created the linked list. So Azad. So when this is given, this should be the head should be the same. So also what I try to confirm is that error dot var and error dot get when n is one and when n is two, there should be only one node. So error dot var should be 0 and should be none. Okay. And the test case for n is n3 is yeah. Okay. So no. So when n is 3, so when each is right head, then 0, 1, 1, and 2, 2. So in this case, it's this node should be removed. So it should be 0 and then 22, and then next is null. Okay, so I've written the test cases. Let me quickly check it. So okay. Yep. Okay. So let me start the implementation. So as I said, if firstly I can say head is in none, and when head dot next is none, I should return none. And otherwise, oh, so one thing I forgot is that, yeah, I'm not giving n. So I have to, I mean, I mean, I have to count how many nodes there are in the linked list. So probably what I can do is here I will define the new method. So count nodes. Yeah. Here I will return node count. So then here, if n is 0, I will return none. And aside from that, I will find the middle index by n divided by 2, and then what I'd like to get is integer less than or equal to x. So I can use master floor, I think. Yeah. Okay. So this is the middle index to be removed. So from here, I will call the remove node method. So this is the index of the node to be removed. Yeah. Then I will return given head. Okay. Yeah. Okay, so what I should do is implement this method. So firstly, for count nodes, oh, oh, I actually don't need this. Okay, so count is head, so okay. Yeah. And for removed node, yeah, probably in the, I mean, real environment, development environment, I can write the test cases for each of these methods, remove node and count nodes. But for, yeah, here, I will just check the only remove middle node method. So remove node. Okay, so this is very tricky. So I can assume that I is larger than 0. No, yeah, yeah, because the in the caller in line 54, if n is 0, it should I will return. So this remove node method. Wait a minute. So, sorry. Yeah. So n is more than or equal to 2. So middle is more than or equal to 1. So in line 71, I can, yeah, make the assumption in this way. Okay. So from here, let me quickly write it. So if I try to remove the first node, what I should do is move only once, move once, then I reach, no, sorry. If I try to remove index 1 from head, I don't have to move any. Yeah, then I will remove the next node. So what I can say is move I minus 1 times, then remove next node. Yeah. Okay. So mm, 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 mm. Then I will remove the current next. So current is so here. One thing I have to make sure that is that current dot next is not null. So the problem is that I have to make sure that the, you know, so if I try to remove the node whose index is out of the range, I mean the exactly the ranks of the ranked list. So in line 83, current.next is none. Yeah, but in a case, it doesn't happen because I remove the middle, which is n divided by 2 master floor. So here I can make it is pretty sure that current.next is not null. Good. So I finished the implementation. So let me work through the code quickly. Okay. With my test cases. So first I will start with run 97 test case. Well, node is only one. So in this case, I will pass this one. So head is not known, yes. And in line 52, I will call count nodes method. So here, this is called with node 0 only as a rank rest, and count it starts from 0, and current is now head, which is pointing to this node. And first three, this current is not known, so count is now 1, and current is count of next which is known. So in the next tab, in line 65, current is known. So I will go out of the while loop and go to line 68 and then return 1. Okay. So in line 54, because n is 1, I will return none. Okay. So line 90 case passes. So yep, I will quickly check the next case, which is NA3 with this one. So first three, head is not known, okay. So next NA3, I will skip I will skip working through count nodes method. So NA3 now, and now in line 57, now middle is now 1. Yeah, so it's okay because I expect this one to be removed. And I will call remove node method. So, okay. So this is called with in this way. So yeah, in line 79, current is not 0. And I will do 1 minus 1 is 0 times. So 1 minus 1 is 0, so range 0. I mean, this is only one time. So now in line 81, current is current next. So this is now 11 node. Yeah. So here in line 83, current next is not known. Yes. So, oh, wait a minute. Sorry, range 0 is 0. So I don't do any iteration. So yeah, sorry. So current is still not 0. So current next is not 0. It is 11 node. And so here, current next. So I mean, current node 0 is pointing to next of next is 22. So now this one is removed. Okay. So in line 58, remove node method worked well as expected. So then in line 60, it will return head, which is 0 with 11 node removed. Yep. Okay, so I can say this test case passed. Yeah. One thing I think I should do is because I noticed that this line 81 is not worked through with current test cases, so probably I should add test case result. Yeah, so in this case, so in this way, I will remove this node. Yeah, so I do on at least one node step in line 81 to reach node 11. So my purpose is satisfied. So yeah, next dot, next is 33. Yeah, okay. So I will run this code with the run code button and try to see it. Okay, good. So this case passed. So I will run this code in the LeetCode platform. Okay, this code, I mean, it accepted. So yeah, with this, I will finish this my today's coding practice. Thanks. So, bye.